Hello, ladies and gentlemen. Let's get into algebra, baby. Let's turn this 7th grade concept into an 8th grade one. All right. So, why does it matter if I know something is a complementary or supplementary angle pair? You might think, great, that's awesome. I know that they equal 90 or 180. Big whoop, Mr. Grapp. But you are failing to recognize the importance of having something equal to something else. See, in math, there's a lot of mysteries. For example, let's just take, for example, this first example down here, right here. For example, we have an angle that has a known measurement. This is 49 degrees. It is a solid, concrete measurement. But this one over here, it's got a mystery to it. It's 4x plus 5 degrees. But I don't know what 4x equals. I don't know what x equals. I can't find out. The closest I can get is just to know that, hey, whatever this angle is, it's 5 plus 4 times another number. It keeps it so mysterious and cloudy. In math, in order to find out a concrete number, I need to have an equal sign. I need to have an equal sign, and it needs to equal to something, usually a number. Without an equal sign, this mystery will never be solved. It'll remain a cold case forever and ever and ever and ever. But once we have an equal sign, it grounds it in reality. It says, hey, we're going to anchor you to this number, and now we're going to have a solution. So a lot of people overlook just the power, the importance of having something equal to something else. It is so important. So knowing that complementary angles equal 90 degrees and knowing that supplementary angles equal 180 degrees, it turns things that are these ethereal, mysterious, misty, smoky numbers and variables that we'll never know. And it says, no, we're going to anchor you to the ground. We're going to find out exactly what you equal. That's an anchor, by the way. Let's close that. That's an anchor, by the way. So there you have it, folks. The importance of this supplementary or complementary equals thing allows us to anchor our variables to something specific and allows us to solve the mystery. So let's use that anchor to solve some mysteries, shall we? Now, I don't know what these angles equal. I do know what one equals. I know what this angle equals. I don't know what this angle equals, and I definitely don't know what x equals. But I've been given some insider information that tells me that these angles together are complementary, meaning they equal to 90 degrees. If that's the case, I can take this and turn it into an equation. Again, without the knowledge of them being complementary, the closest I can get is this, 49 plus 4x plus 5. This is not an equation, this is an expression. The closest thing I can do to solving this mystery is combine the constants and get a simpler expression. But once I add the equals 90 degrees to it, now I've grounded it, I've rooted it in reality, and I can solve for x. Equals, so important. It turns an expression into an equation, and that is powerful. So how do we solve this equation? Well, we need to get it to a point, perhaps you remember this from quite a while ago, we need to get it to a point where it's just x equals and then my answer. X equals and then my answer. To do that, we're going to move numbers to the other side and eliminate coefficients. So let's try that right now. First thing I want to do is I want to reorganize this. I want to get my variables on one side and my constants next to each other, and then I'll start moving things around. So variables are numbers that have letters next to them, right? So 4x is a variable. Constants are numbers without letters next to them. So that would be 49 and 5. And they all are equal to 90 degrees because it's a complementary angle pair. Now I'm going to simplify this by adding these two together. 4x plus 49 and 5 is 54. Cool. So I get 4x plus 54 equals 90. Excellent. Simplified, but now we're going to take it a step further because I still have numbers. I've got that 54 and I've got that 4. I want it to just be a concentrated x equals my answer. So we're going to employ some strategies from a while back. First strategy is we want to move the constant to the other side. We want all the just regular numbers on the right side and all the variables on the left side. So let's move this 54 over. To do that, I get 4x equals 90, and then I'm going to move the 54 over. But remember, when we move anything to the other side of the equation, meaning we move it to the other side of the equal sign, we have to change it from a positive 54 into a negative 54. When we move it across this threshold, it changes its sign. All right, now we'll simplify. This stays for x. 90 minus 54 is 36. So 4x equals 36. And the last thing I want to do, because I'm so close to just saying x equals a number or x equals an answer, is I need to get rid of that 4. To get rid of a coefficient, we divide. Divide both sides by the coefficient, divide by 4. On the left side, the coefficients cancel out, and I'm left with x equals, and then 36 divided by 4, 36 divided by 4 is 9. And there we go. What was once a mystery, clouded in smoke and mirrors, we now have an answer. X equals 9. And if you don't believe it, or if you're a little uncertain, all you have to do is go back and plug 9 back in to wherever the x was. So for example, this 4x, we could replace this with a 9, so 4 times 9, and then we would do the math. 49 plus 4 times 9 is 36 plus 5 equals 90. If everything works out, this should equal 90. So let's get the calculator. 49 plus 36 plus 5, 90 degrees. Perfect. So x equals 9. Again, this equal sign gives us the power to solve the mystery. Without the equal sign, we can't do anything. Well, that's not true. We can simplify, but we can't solve. Equals lets us solve. Let's solve some more mysteries. Okay, let's solve this one right here. Okay, we're going to add them up. They're going to equal 90 degrees. But the first thing I want to do is I want to reorder them. I want all my variables on my left-ish and then my constants next to those and then equals 90. So my variables would be 5x and 3x. So let's reorganize. So 5x plus 3x plus 2 plus 8. So I've got my variables, then my constants, and they equal 90 degrees. Okay, sweet. I'm going to combine. So 5x plus 3x, that would just be 8x. 2 plus 8, that would be 10. So it's 8x plus 10 equals 90 degrees. I could put little degrees here. I guess that's, an important thing to do. I'm going to move my positive 10 to the other side. So that will get me 8x on the left side equals 90 degrees minus 10 degrees, because I'm moving a positive to the other side, it becomes negative. So then I'll have 8x equals 90 minus 10 is 80. And I want to get rid of that 8, so I'll divide. Divide by 8. Divide by 8. Once again, the coefficients cancel each other out. And all that's left is x equals 80 divided by 8 is 10. X equals 10. And once again, you don't believe it? Plug it in. Prove it. So let's do it. I am saying x equals 10. So I'm going to replace my x's with 10s. 10, 10. What's 5 times 10? 50. 3 times 10? 30. Plus 2, plus 8. If everything works out, this should equal 90 degrees. Let's find out. 50 plus 30 plus 2 plus 8, 90 degrees. I never have to be uncertain about this. I can always be certain that I have the right answer. I just have to plug it in. All right, next example. Ooh, this one looks a little bit easier. Less things to add and combine. So together, they're complementary. So if I add them up, they're going to equal 90. So 37 plus 5x plus 3 equals 90. That's what I'm assuming. Not assuming, that's what I know. Let's reorganize it. Let's have variables on the left side and then constants. So 5x plus, it's a positive 37, plus 3 equals 90. Okay. Now let's do some combination. 5x doesn't have anything to add, so I'll just keep it as 5x. 37 plus 3 is positive 40 equals 90. Then I'm going to move my constant to the other side. So I'll have 5x equals 90. Again, it was positive 40. When I move it over, it'll become a minus 40. And now I'm going to simplify, right? 5x equals 90 minus 40, which is 50. Looks like we're going to get a very similar answer. Divide by 5. Divide by 5, slice and dice, and I'm left with x equals 50 divided by 5 is 10. But Mr. Grapp, that's the same answer as before. How do I know it's true? How do I know it's accurate? Well, plug it in. Change that x into a 10. See if we get a good answer. 5 times 10 is 50. Plus 37 plus 3. If everything works out, this should equal 90. Grab the calculator and find out. 50 plus 37 plus 3, 90 degrees. Bam! Worked out perfectly. All right, let's do one more mystery. We're going to solve one more mystery. Once again, these are complementary. And I want to stress, these aren't complementary because they look complementary. They're complementary because I was told earlier in the question, hey, these are complementary angles, find x. If you're not told they're complementary, you can't just say they are. You have to be told, dude, these are complementary. You can find the answer now. So just keep that in mind. You can't just willy-nilly decide, oh, they're complementary. You're going to be told. These are complementary, meaning if I add 2x plus x plus 18, they will add up to 90. Now doesn't look like we actually have to reorganize it. 2x and the x are next to each other. What's 2x plus x? 2x plus x is just 3x plus 18 equals 90. All right. Now I'm going to move my 18 to the other side, just like before. We get 3x equals 90 minus 18, because we're moving the positive, it becomes a negative. That would get me 3x equals 72. And then I will divide by 3. Slice and dice. X equals, what would that be? I know it ends in a 4. And it'd be 60 plus 12, so 24. There we go. X equals 24. And if you don't believe it, I don't believe it, Mr. Grapp, then plug it in. Change this x into a 24. And then find out. What's 3 times 24? 3 times 24 is 40, 50, 72 plus 18. Does that equal 90? Let's find out. 72 plus 18, 90 degrees. There you go. Worked out, my friend. All right. There you have it, folks. Complementary angles. If I know they're complementary, I can set them equal to 90 degrees, and then I just solve it using algebra. Combine my like terms, move my constants to the right side of the equation, and then divide by the coefficient to find my final answer. All right. In the next video, we're going to do the exact same thing, but with supplementary angles. I'll see you there.